Hi folks, welcome to lecture 16, and in this lecture we'll be taking a look at molarity and dilution. So it's really pharmaceutical calculations part 2. So first we just take a look when sums go bad. So in 1999, Institute of Safe Medication Practices. Now this goes on all the time. This is just one example. This is kind of a particularly interesting one. So doses were given out in terms of grains. So 0.5 grains was mistakenly read as 0.5 grams. So it's a very, very easy mistake to make, I think you'll agree. Just the difference between grain and gram is really just like a little hook joining those. So as a result then, so there's a grain on the left. It's about 0.065 of a gram. And there's a gram on the right. So there's a scale, guys, of about 1 is 15.4 times. So it was an overdose, like it was a 15-fold overdose, which could easily have been fatal. So there's just talking about it. So from now on, they only use the metric system. And also just an interesting thing, in medical context, you always write the word micro. You wouldn't write microgram, because again it could be very easily interpreted as milli. That's meant to be a micro. So you see when it's written like that, it'd be very easy to see how that could be misinterpreted as an milligram. So for that reason, guys, whenever micrograms are prescribed, now this is only in a medical, in a hospital, they'd write micro G like that. So just to try and avoid these errors. So now we're going to take a look at molarity, again more from the point of view of using the triangles than me trying to teach anything about chemistry. So molarity, guys, is a method of expressing concentration. It's the amount of stuff, the moles, dissolved in 1 liter. And the capital M is used as its unit. So similarly, as we've seen before, whenever a function can be written like this, A is equal to B by C, we can write a triangle with A on the top and B, C below. So this is now our molarity triangle, describes the relationship between moles, molarity and liters. And again, we just cover over the term of interest, and that tells us the relationship between the remaining variables. Moles is molarity by liters, or by volume sometimes. Liters is moles over molarity, and molarity is moles per liter. Very important to convert all your values to liters in order to do these calculations. One thing though, guys, that's very important, the other triangle we saw was the moles triangle. We had grams, moles by molecular weight. In all the questions that follow, guys, regardless of anything else, use the question to find the moles first. And then you can transfer to one triangle, from one triangle to the other. So always find the moles first. It never asks for it in the question, very rarely, but that's your first goal. And once you find the moles, then you can move into the other triangle and solve out for your unknown. So we'll take a look, guys, but that's a really good tip. Just look for the moles regardless. So determine the molarity of 27 grams of hydrochloride and made up to 500 mils. Also, guys, pay attention to the language. This is made up to 500 mils, so that's our final volume. Now, we did this question in lecture 15. The molecular weight of HCl is 36. We're looking for the moles, so it's grams 27 over 36. That's our moles. And like I said, we did this in lecture 15. The moles is 0.75. Now we're going in and taking a look at the other triangle. We want to determine the molarity. So molarity is moles over litres. Molarity, moles 0.75. And litres, guys, we want to go from 500 mil. That's 0.5 litres. And we can use our unit conversions to confirm that if we need to. This is moles over litres. So that's what gives us our unit then of molarity. And then, guys, we've got multiply top and bottom by 100. We have 75 over 50, which is 3 over 2. So our answer is 1.5, a molarity of 1.5. How many grams of formaldehyde? My limited amount of chemistry there. Is there in 600 mils of a 2 molar solution? So now, guys, we're given the volume and the molarity. So we use this then to calculate the moles. Like I said, always find the moles first from whatever information you're given. We need to get the molecular weight. We have 1 carbon, 12, we have 2 hydrogens, 14, and we have an oxygen. So the molecular weight of formaldehyde is 30. Now, we can't use that at the moment. But first thing we're going to do is work out our moles. So moles, guys, is molarity 2 by volume, which is 0.6. So the number of moles is 1.2. Now we know the moles, guys. We can use our molecular weight in the second triangle. The grams required is moles by molecular weight. So in this case, we're going to have grams is moles 1.2 by the molecular weight, which is 30. And this will give us then 36. So our answer then required is 36 grams. So again, guys, the key all the time is to find the moles first. Now this problem is quite complex, but it's very good because I can ask the same question in lots of different ways. The one thing to note, guys, is there's no column for moles, but that's the first thing we do all the time. So we're going to take a look at each of these in sequence using our triangles. So NaOH, sodium hydroxide, that's got a molecular weight of 40, guys. I won't spend ages working that out. Now we want to find the number of moles. We have molecular weight, we have grams, so we can find the moles. Moles is grams over molecular weight, 16 over 40, divide top and bottom by 4, 4 over 10, which is 0.4. So that's our moles. And even though it's not asked for in the question, half the marks would go for finding that value, because you must find it. It's one of the stepping stones to the solution. Now, guys, we have the moles and we know the volume, so then we can calculate the molarity. Molarity is moles over litres. So just from the line above, the moles is 0.4. Liters, guys, 200 mils converted to liters is 0.2. Multiply top and bottom by 10. So the molarity of the solution is 2 molarity. 2m, capital M. And that's our answer. We look at the next one. Calcium carbonate, one of my favorites because it's got a molecular weight of 100. Now in this case, guys, we're given the volume and the molarity. So we're going to calculate the moles using those values. We can't calculate the moles using the second triangle yet because we don't have enough information. We only have the molecular weight. We don't know the grams. We don't know the number of moles. So moles, guys, is using our triangle, molarity by volume or by liters, which is 0.5. This will give us 0.6. Half, really we're asking what's half of 1.2. So that's our moles, number of moles. And now we can move to the second triangle. We know the number of moles. We know the molecular weight. Grams is moles by molecular weight, which is 0.6 multiplied by 100. So the answer then is 60 grams. And we look at one more, the last one, HCl. Molecular weight of 36. We know the grams. We know the molecular weight. So first thing, calculate the moles. Grams over molecular weight. So 9 over 36, which is a quarter. Divide top and bottom by 9, which is 0.25 moles. Now we can calculate the molarity. Oh no, we can calculate the volume. We know the molarity. We know the moles. So volume, liters, is moles over molarity. So in this case it's 0.25 from the line above. The molarity is 2. So the volume, guys, is 0.125 liters. We try not to use a value less than 1 with measurements. So we bring it down to the next available prefix, which is milli. So the correct way really to write our answer is 125 milliliters. We don't like this value here, guys, being less than 1. So that's why we drop down to the next available prefix. So now, guys, pause the video and have a wee go at these problems yourselves. Here's your molecular weights. Use these molecular weights, guys. Don't go to Google. And I'll let you guys have a go at them. Same principle, guys. Calculate the moles first, regardless of what's asked in the question. Now we're going to take a look at dilutions, guys, and again it's really only a very light look at them, but similar to the previous kind of to lecture 15 as well. Really, guys, we're just looking at the kind of maths of stuff, the maths around working with units and stuff like that. So the maths is actually not too bad. It's really just, are we multiplying values or are we dividing values? Then making sure all our units are consistent. So in dilution calculations, guys, what generally happens is we have an amount of stuff. Remember, that's your moles. So there's a certain number of dots there. I think I counted them once. I can't remember. I won't do it again. It's about 15 or something. But when we dilute, guys, there's the same amount of stuff. The moles hasn't changed. And if we remember from our triangle, our molarity triangle, moles is molarity by liters, which is really concentration by volume. So the moles are the same before and after the dilution, guys. And as a result, this formula drops out. Remember, moles is volume by concentration. We were calling it molarity by liters, but it's the same thing. So the moles at the start of the dilution are equal to the number of moles at the end. The amount of stuff we have hasn't changed. So we write the formula like this. This is how we'll be using it. And in any problem, guys, essentially I'll be giving you information about 3 bits and asking you to solve for the unknown bit. That's the way it'll go all the time. So it'll be a bit of multiplication, a bit of division. There'll be units involved. The main thing is, though, is make sure your units match on both sides. That's really what I'm looking for. So we take a look. So again, guys, this is really just units dressed up as dilution problems. So we're told 200 ml of a 0.5 molarity solution is, we would say molar, I think, 0.5 molar solution, to say shorten molarity. 0.5 molar solution is diluted to 1 litre. So straight away, guys, we've got different units going on. We need to equalize those. 1 litre we'll write as 1,000 mils. Always come down to the smaller units. Determine the molarity of the diluted solution. So really, guys, what you have to ask is, what was my initial volume? What was my initial concentration? What was my final volume? What was my final concentration? From the question, we know these values here. So 200 mils, that was our initial volume. 0.5 molar, that was our initial concentration. 1,000 mils, 1 litre, that was our final volume. And we want to get CF. What's the final concentration? How we get there, guys, is we simply divide both sides by 1,000 mils. And that gets us to here. Now, looking at the units first, guys, the mils will cancel out. So our units are going to be molarity, molar. Then, guys, we can say, well, 0.5 by 200, that's a half. A half of 200 is 100 over 1,000. That's going to give us 0.1 molar. And that's our answer then. So the final concentration is 0.1 and a capital M. Taking a look at a similar problem, again, it's just about what's my initial volume, initial concentration, final volume, final concentration. You'll be given 3 of those, and we'll be asked to find the unknown. So in this case, initial volume 300 mils. Again, bring everything to whole numbers where possible. 0.4 molar, that's our initial concentration. And it's diluted to a 0.15 molar final solution. The question is determine the final volume. So now we want to find the final volume. We're going to divide both sides by this unwanted bit, 0.15 m. Now 300 by 0.4. We'll do the units first. The molarities will cancel. So my answer is going to be in mil. And that makes sense. What's the final volume? 300 by 0.4 is 120. Again, 300 by 4 is 1200, one decimal place. That's how I'm doing this. Over 0.15. Now guys, 15 goes in here once. 15 will go into 128 times, so I've got 8 over 0.1, multiply top and bottom by 10. So my answer then is 80 mils. So what's the final volume? Sorry, that's wrong. That's we'll just pause there. So we look at another example. 0.3 liters of a 0.4 molar solution needs to be diluted to a 0.15 molar solution. So it's quite a mouthful. But really we just take a look at, well, what are we looking for? Initial volume by initial concentration, final volume, final concentration. We're given these three. I'm going to bring my liters down to mils. I just prefer dealing with whole numbers. So that'll be 300 mils by 0.4 is equal to VF by 0.15. So I want to get VF on its own, guys. So I need to get rid of this. So I'm going to divide both sides by 0.15 M. The reason why I divide, it's because the inverse of multiplied. So I divide both sides by 0.15 M. Now guys, when I multiply the top, 300 by 0.4 is going to be 120 mils. I'll actually just do the units first. I should have done them. The molarities will cancel, so my units will be in mils. On the bottom, guys, I've got 0.15. Now these are tricky, so don't jump the gun. Multiply the bottom by 100, multiply the top by 100. Now 15 will go in to 120 8 times. So that gives me my answer then. 800 mils is my final volume. And if I wanted to express it in liters, I just use 0.8 liters. One more. 750 ml of solvent are added to, okay, added to, guys, be careful of the language. So 750 ml of solvent are added to 50 ml of a solution to achieve a concentration of 1.5 grams per liter. So this is worded awkwardly, guys, and you need to kind of divine what's going on. We started with 50 ml of a solution. We don't know its concentration. What we ended up with though is we added 750 ml, so we're going to have 800 ml as our final volume. So that's why the wording is very important. My final concentration is 1.5. Now it's grams per liter, that doesn't matter, that's just the concentration. It's the exact same as molarity, it's a different way. Molarity is moles per liter. This is just describing it in terms of grams per liter. So our units will come out in grams per liter. Whatever we feed into the formula is what's fed out. Our initial volume is 50 mils. So it's very important, guys, to read the question carefully. Are you given the final volume, or are you given a mixture of things that you have to add? So we feed these values into the formula. And now I want to get the initial concentration on its own. I want to get rid of this. It's joined on by multiplication. So I use the inverse, divide both sides by 50 mil. Now we just look at the units, guys. The milliliters will cancel out. So my answer is going to be in grams per liter. We'll just do this bit first. Divide top and bottom by 10. 5 will go into 80 16 times. Again, you can work that out. And then 16 by 1.5, well, that's 1.5 times 16, which is 24. So that's my answer then, 24 grams per liter. And that's the concentration, the initial concentration, before we diluted it, pretty much 16-fold. So now, guys, pause the video and you have a wee go at these ones. So just be aware, guys, there we're given the total volume, the final volume. Here, guys, we're given a mixture. So be careful as you navigate your way through these problems. Here's a final volume, 200 mil. And here again, we're given the final volume. So just watch out, guys, the wording of the question is very important. So, like I said, pause the video, have a go at those. And that finishes us up, guys, for lecture 16. So thanks very much for watching, and we'll meet again for lecture 17.